Hi everyone. In this video, we are discussing problem number 120, triangle. It's a medium level problem from Leetcode. Let's read the problem statement. Given a triangle, which is an array, we need to return the minimum path sum from top to bottom. Okay, so they're explaining what it means. Okay, for each step, you may move to an adjacent number of the row below, or more formally put, if you are at index I, on any given row, on the current row, then we may move on to either the index I or index I plus 1 on the next row. And here they have given one example also. Check this example number 1. The triangle is nothing but list of lists, right? So you have the first list, which is just 2, and the next list is 2, 3, 4, and then you have 6, 5, 7, and then you have 4, 1, 8, 3. So what it all means, when you actually draw it, you'll understand. And the output is 11. So the explanation goes like this. So the list of lists, what it is what we are using to form a triangle. The 0th level of the triangle is 2. That is the vertex, the top vertex. Next level, the next row, we have 3 and 4. Its next row, we have 6, 5, 7, this list, okay? Its next row, which is the very last row, we have 4, 1, 8, 3, right? And we need to find the minimum path sum. You see, we have so many different paths from the topmost level to the bottommost level. The topmost row to the bottommost row, we have so many different paths. Okay. So out of all those different paths, we need to find the path that gives us the minimum sum, which is, in this case, they have underlined 2, 3, 5, 1. This will give us the least path sum, and that least path sum is 11. But how do we know this is the one that is going to give us the least path sum? And is there any way we can approach it more systematically? We will discuss. Instead of just doing trial and error, is there any way to approach it systematically? There is a way to approach it systematically. So let's head over to whiteboard, where we will actually draw the triangle. Okay, so this is not that very clear. So let's check more examples where we actually draw a triangle. We will draw different triangles of numbers, and we will find different paths, and let's try to minimize the path sum. So now let's go to whiteboard. Check this example. So we have this triangle, right? The first row is having 1 number, the second row is having 2 numbers, the third row is having 3 numbers, 4 numbers. If there is another layer, then 5 numbers. If there is another layer, then there are 6 numbers, so on. Okay, that structure is very clearly defined in the problem statement itself, right? So it's a triangle of numbers, right? Any given row will have exactly 1 number more than the preceding row, right? Okay. So there are so many different paths from top to bottom. Of all those different paths, our aim is to find the path giving us the least sum. Okay. So how to approach this? Okay. So why not we start at the top, and at any given point, we choose the least number from the next row that we can reach. In the sense, yeah, another very important thing I have to say about the path is that if you are at this particular element, you can go here or you can go here, right? That is obvious. You just have 2 options. Whereas when you are at this particular element, you can go to 4 or you can go to 7. There is no way you can go to 3. That is not allowed. If you are at any given element in a row, we can go to the corresponding element in the next row, or its very next element in the very next row, the same row. I mean, do you get this? If we are here, for example, we can go to this element, which is in appearance appearing to be the left child, or you can go to this element, which kind of appears to be the right child. If you look at it like binary tree, it's not at all a tree. I'm just telling you for example's sake. Did you understand this? Okay. So you can never go from 7 to 2, or you can never go from 7 to 1. Those are not valid paths, right? Okay. So why not we take this top-down approach? Okay. So this is where we are starting. At any given point, please understand this is not a graph. I mean, this is not a tree. We don't have any binary tree here. So we cannot actually use the terms such as left child and right child. Just for the sake of convenience, I'm using it. Okay. So we'll treat it more formally in a while. Okay. So this is where we are currently. I'm taking the left child because that number is smaller. So of course, I'll expect the sum to be smaller. Okay, why would we even want to consider the other child, which is 10, which is much bigger than this? It is definitely going to increase the path sum, right? Okay, so this is where we are currently. Now, again, there are two children, 3, 4. I'll choose the smaller one because our aim is to minimize the path sum, right? Fine, so this is where we are currently. Again, it has got two children, 1, 2. I'll pick the one which is having the least value. So this is the path. Our aim is to go from the topmost element to anywhere in the bottom row. Anywhere, you can land anywhere in the bottom row, it doesn't matter. But the only objective is to minimize the path sum. So what's the path sum? 1 plus 2 plus 3 plus 1 is 7. 7 is the path sum, and that is the least path sum. If you take any other path, okay, imagine in the beginning only, instead of going from 1 to 2, if you are going from 1 to 10, we took the right child. Already the path sum for this path, this incomplete path itself is like 11. Do you get this? Okay, so it's not a very good idea. Oh, by the way, you can even have negative numbers in this tree. So that is another thing to keep in mind. Okay, but in this specific example, I'm telling you that already it's 11 and the other numbers are positive. So if you add them, there is no way you will get a number which is less than 7. Okay, already we got 7, right? So any other path you can try. Okay, so I'll start at this point. I'll take this particular child. What if instead of 3, I'll take 4 and then I'll take 2. What is this path sum? It is 9. Definitely it's not smaller than our previous path sum, which is 7, right? So there is no other path sum which is smaller than 7. Do you get this? So clearly it looks like our approach is right. Our approach is valid. Okay, at any given step, out of the two children, you pick the smaller child and you keep repeating the process. So that way we will eventually get the least path sum. In this case, it's 7. So now I'll give you another example. Okay, I'm taking the same example, I'm slightly modifying. I'm just adding another layer that will make us question our assumption. We will have to really rethink our approach. Okay, there is something fundamentally wrong with this approach. You will know that in a while, right? Check this. I'm now introducing another layer. Okay, so I'm adding one more row, right? Which is the last row is 50, 51, 52, 53, 1. Okay, now what was our path? Initially, we took this path, right? We took this path. Now imagine we continue along the same path. Now we only have two options. You can choose the left child, which is 50, or the right child, which is 51. I'm reminding you again, it's not appropriate to use left child, right child here, but I'm just using those terms only for the sake of convenience. Okay, anyways, so this is our path. And here we have reached here, this one, and we are going to choose one of these two children, right? 50 or 51. Okay, we'll choose 50. Now think about it. Do you really think that this is going to give us the least path sum? What is the path sum here? So till here it was like 7. And now we are adding 50 to it. So path sum is 57. It's 57. Whereas you look at this particular path, what is the path sum? It is 31. It's significantly smaller than this path sum, right? Do you see the problem here? What is our approach? What is our original approach? We started here. At any given step, we are choosing the smaller of the two child. We are choosing this. Then again, we are choosing the smaller of the two children. We are choosing this. Again, we are choosing the smaller of the two children. We are choosing this. So do you understand that this approach is exactly what is leading us towards the problem? The problem is the last row where the first 4 elements are so big, like 50, 51, 52, 53, right? So every given step we are optimizing, but eventually where we are ending up is not an optimized solution. Okay, that is far from being the least. Okay, now think about it. Had I taken this path, okay, this is where we are starting. I'm choosing 10. Initially, it will look like a very stupid idea. Why would we consider 10? Because the sum is definitely greater. Yeah, right now, at this particular point, at this level, it's greater. Okay, again, choose 7. It appears to be greater. True. Choose 6. Again, it appears to be greater. But eventually, the overall sum is smaller. If you deviated at any point in this green path, if you deviated even a little, no matter what, you will eventually end up here in one of these four numbers. If you deviated anywhere a little bit, for example, you came all the way till 6, but instead of 1, you choose 53. It's a very silly idea. Okay, you came all the way till 7, but instead of choosing 6, you're choosing 3 because 3 is smaller. Then again, you're in a trap because now you're forced to choose between 52 and 53. It's not a good idea. Okay, same here. Okay, we reached till here, and instead of choosing 7, we are choosing 4 because it's a smaller number. Then again, next step, you're choosing 2 or choosing 3. You're going to eventually end up in one of these four numbers in the last row. So the best solution is this solution. Okay, but until I introduced this last row, it appeared as though this is the worst solution. It was actually the worst solution for the previous example, but the moment I introduced the last row, our equations are now entirely different. So what if I introduce another layer? Then it is going to be even more drastically different. Okay, so what exactly are we supposed to do? So this is not, the top-down approach is not going to work, right? We are going to take bottom-up approach. In this problem, that's the best way of solving. We are going to take bottom-up approach. So how it works, let's see. So follow this carefully. We are going to go from the bottommost row to the topmost row, which is just having one single element, right? Now, of all the paths that is leading to this particular point, the least path is a path of sum 50. You may wonder, like, where is the path? Okay, we are just considering just that one node, that one point itself is a path, right? Of length 0. Okay, so the path sum is 50. Okay, of all the paths that are leading to this, again, when I say leading, not from the top, listen, when I proceed further, you will understand. So when I say all the paths leading to 51 means I'm not talking about all the paths starting from the top node leading to 51. I'm not talking about that. We are taking bottom-up approach. Just bear with me for a while. You will understand what do I mean. So of all the paths that are leading to 51, the least path sum is 51. Right? We are taking bottom up. Nothing is leading to 51 from the bottom. Nothing is leading to 52 from the bottom. Nothing is leading to 53 from the bottom. There's nothing. This, we are already at the bottommost layer, right? Okay, so that's the idea. Okay, of all the paths that are leading to 52, which is basically nothing, the path with the least sum is 52 because just that one number itself is counted as path. Again, same story, same story. Fine. Now we'll go to the next layer. Right, the next row from bottom. Okay, of all the paths that are leading to 1, the path with the least sum is 50 plus 1. Had I chosen this path that is leading to 1 from the bottom, its value will be 52. No, we don't want that. Okay, so I'll go with 51. Okay, so let me put it somewhere here. I'm color coding so that you can clearly see what's going on. So 51. Right? Okay. So of all the paths that are leading to 2 from the bottom, the least one, the least path sum is going to be 51 plus 2. That is going to be 53. Had I chosen this route, it'll be 54. No, we don't want that. So I'll go with 53. Okay. So let me mention 53 here. So again, same story. Of all the paths that are leading to 3, the path with the least sum is 52 plus 3, that is 55. The other path will give us 56. Okay. We'll go with 55. Repeat the story. Of all the paths that are leading to 6, the path with the least sum is 1 plus 6, that is 7. The other option will be 59. We don't want that. Okay, so 7. So do you understand all the numbers that I'm writing in purple? These are the path sum that is leading to that particular element in that row, right? Of all the paths that are leading to 6, the path with the least sum is this path 1 6 and its sum is some value is 7. Okay, repeat the process. Go to the preceding row. Of all the paths that are leading to 3, the path with the least sum is, now please understand, never consider 1 or 2. That is not the choice. You consider 51 and 53. Consider 51 and 53. So till this point, the path sum is 51. Till this point, the path sum is 53. So if I go from this direction, okay, if I go in this direction, then the path sum will be 56. We don't want that. I'll go in this direction. What is it? 51 plus 3 is how much? 54. Okay. Of all the paths that are leading to 4, the path with least sum is, choose between these two path sums, 53 and 55. I'll choose 53 because that is least. Okay, so 53 plus 4 is 57. Okay, so till this particular point, the least path is 57 when you go from bottom. Okay, of all the paths that are leading to 7, the path with the least sum is, we have two path sums below that, 55 and 7. Now, if I go from this direction, from 3 to 7 if I'm going, so I will have to carry this 55 plus 7, that is going to be like 62, not required. 7 plus 7, that is good. Okay, this is the least path sum, which is 14, right? Okay, again, repeat the story. Of all the paths that are leading to 2, the path with the least sum is, you take this route, you go from 3 to 2, right? You go from 3 to 2, not 4 to 2, because that will have more weightage, right? More path sum. So 3 to 2, if you go, it'll be 54 plus 2 is 56. Okay. Now, same thing. Of all the paths that are leading to 10, the path with the least sum is, you go from, when you go from 7 to 10, because look at the path sum till 7, it is 14. So 14 plus 10 is 24. Had I chosen this, it'll be 67. Okay. So what is it? We'll go with this 24. 14 plus 10 is 24. Again, the last level. Okay, of all the paths that are leading to 1, the path with least sum is, you have two options, 56 and 24. We choose 24, right? Because if I go from 10 to 1, it'll have least path sum, that is going to be 25. Otherwise, here, if I take this approach, it'll be 57, right? Our aim is to minimize, so it'll be 25. So 25 is the least path sum, right? So this is our approach. This is exactly what we're going to code here. So first, let's whiteboard our code and then we'll go to LeetCode, right? So first thing that I'm going to do here is I'm going to import a package called collections, because from that particular package, from that particular library, we are going to make use of something called as default dictionary. It's same like the regular dictionary in Python. The only difference is when it comes to default dictionary, we can assign a default value for all the keys. Hence the name default dictionary, right? So first let's import this package and then let's capture the number of rows in the triangle. For example, in this particular triangle, 1, 2, 3, 4, 5, there are 5 rows. So how do we get that? Okay, row is length of triangle. And now, right now we are creating a dictionary called path sum, default dictionary it is. Okay, so default dict of lambda, and we assign the value as 0. We are using lambda function to assign the path sum as 0. By default, we are assigning the path sum for every single element in this triangle as 0. And then we are going to constantly keep updating it. Let's see how to do it. Okay, so now we are going to introduce for loop, in fact, nested for loop. The outer for loop is to traverse through the rows of this triangle from bottom to top. And the inner for loop is to traverse the elements in any given row. Did you get this? The outer for loop is to traverse the rows. I'm going to go from the last row to the first row. And the inner for loop is to traverse through the elements. For example, if this is the row under consideration, we are going to consider the 0th element, the first element, the second element goes on, right? So that is the role of the inner for loop. So we will have to create two for loops. So for I in range of 1 comma row plus 1, I'll explain why it is 1 comma row plus 1. Okay, so we are starting at 1. We are not starting at 0. We are starting at 1. I'll explain that. And why row plus 1? Row plus 1 because you know how Python works, at least in Python 3. The range, when you write 2 comma 7, 2 is counted, but 7 is not counted. It's going to stop at 6. So I want to count the row itself. So that is why I'm going as far as row plus 1, right? And now the inner for loop will use a different variable. For j in range of, you see the row under consideration is triangle of row minus I. I'll explain that. This requires some explanation. We'll discuss that. For j in range of length of triangle of row minus I, I'll explain, right? You see, what is the least value of I? I is 1. Look at this. Range of 1 comma row plus 1. So the least value of I is what? 1. Let me scribble over here. So the least value of I is 1. Now, what is triangle of row minus 1? Row is nothing but the length of the triangle. So when you write triangle of row minus 1, triangle is, if you remember, triangle is list of lists. And every single list inside the main list is representing a row. Okay, so when you write triangle of row minus 1, row itself is the length of the triangle. So triangle of row minus I is 1 for now, is going to be referring to the last row. Do you get this? So for j in, the range of length of the last row is how you interpret it. So you're just going through all the elements. That is what it means. Then the next value of I is 2. Now what is triangle of row minus 2? Again, row is the total number of rows in the triangle, right? And I is 2 for now. I is 2. So row minus 2 means we are talking about this particular row. This is row minus 2. Do remember, all the arrays are 0 indexed here. Okay, so you will have to adjust the numbers, the indices accordingly, right? Okay, so row minus 2 means we are talking about this particular row, right? So for j in range of length of triangle of row minus 2, it means we are traversing through the elements of this particular row, and then you keep updating I is 3 means that you're going to this row, and it goes on, right? And what will be the last value of I? What will be the last value of I? I is row itself. When it is row plus 1, that is not counted. We are going to stop at row, I told you. So the last value of I is row itself. So what is this triangle of row minus row? That is going to be triangle of 0. Triangle of 0 in the sense we are talking about this row, right? The topmost row. Do you get this? And we are considering the only element in that particular row. Is that point clear? So what exactly are we supposed to do? The path sum is a dictionary, don't forget. Okay. The path sum of the key is row, comma, column. Dictionary is basically key value pairing, right? So the key is row, comma, column. I'm going to take the tuple row, comma, column as the key, and the corresponding value is the path sum, like the least of all the path sum leading to that particular row, comma, column, that particular, cell, that particular element, right? So path sum of row minus I, because I told you that we are at ith row from the bottom, right? So row minus I, comma, j. J is the jth element at that particular given row. Okay, so path sum of this key, the key is the index row minus I, comma, j, is whatever is the value of the element at that particular row and that particular column, which can be obtained like this: triangle of row minus I of j, right, plus minimum of path sum of, okay, what are we trying to do here? The path sum of the element at this particular row, comma, this particular column, right? This particular row, comma, this particular column. For example, this is the element we are talking about, let us say. Okay, what is the least of all the path sums leading to this particular element? You will have to count that particular element's value itself. That is exactly what we are doing here. Plus minimum of these two path sums. Minimum of these two path sums. How do you address those 2 points? So whatever is the row number here, the row number here will be one number more. And whatever is the column number here, if you think about it, whatever is the column number here, you will have exact column number here. Because they both are having same index, even though it looks like it's a little bit to the left, they both are actually having same index. What I was previously referring to as left child for any given point is actually going to have the same index, but in the next row. Are you getting it? Any element can be taken as an example. Okay, so for example, choose this particular element. What is its index at that particular row? 0, 1, 2. Now, what is its left child? I mean, like what appears to be its left child? This number, 52. What is its index? 0, 1, 2. Are you getting it? So for any given node, we shouldn't be calling it node. Its corresponding left child, yeah, we shouldn't be calling it left child. But the node and its left child, what appears to be its left child, they both have the same index. Right? So let's make use of it. So it's minimum of path sum of, how do you address those 2 points? Row minus I plus 1, comma, j, comma, path sum of row minus I plus 1, comma, the next element, which is obviously j plus first element. So this is the crux of our algorithm. Right, whatever I just now wrote in black is the crux of our algorithm, right? So once we are done with running these 2, for loops, these nested for loops, what are we supposed to do? So finally, once we are done with this algorithm, we simply have to return the path sum of the topmost element, which is basically the path sum of 0, 0. That is the 0th element at the 0th row, right? So it's path sum of 0, 0. That's it. Now let's head over to LeetCode and code it out and see how it works. So first let's import the package called collections, and then let's count the number of rows in this list of lists called as triangle. And then we'll create this dictionary called as pathsum. It's a default dictionary where we pre-assign the values. Okay, hence the name default dictionary. So we are using lambda function to pre-assign the values, and all the pathsums are initially set to 0, and which we are going to overwrite in a while. And like I told you, we are going to create nested for loops. The outer for loop is to traverse through all the rows from the bottom. That is most important because we are taking bottom up approach, because we clearly saw that the top down approach is failing. So for I in the range of 1 comma row plus 1, and for j in the range of length of triangle of row minus I, and here comes the meat of our code. Path sum of, we are giving the tuple as the key, row minus I comma j is, let's copy paste this, is triangle of row minus I of j plus minimum of path sum of row minus I plus 1 comma j comma path sum of row minus I plus 1 comma j plus 1. So once we run these two for loops, like the nested for loops, we will have to return path sum of 0 comma 0, which represents the topmost element, right? Let's test run our code. It should work. Yes, it did. Okay, so now actually let's submit our code to see how it performs in all the test cases. That's good. Our solution is accepted, and specifically our runtime is also pretty good. I hope you all understood the solution. Thank you for watching.